Okay, so we're going to go through a couple of percent yield example problems. Okay, according to your stoichiometric calculations, you were supposed to produce 104 grams of calcium carbonate. Okay, so suppose according to the calculations, you're supposed to produce this. Okay, so what this means is, that is, because you're calculating it, this is your theoretical yield. Okay. In the lab, after mixing the reactants, you only produce 93 grams of calcium carbonate. What is your percent yield? Okay, so this is what you actually did. So this is your actual yield. Okay, so the formula that we got from the lecture was your actual yield divided by your theoretical yield times 100. Okay, I'm doing this shorthand. So actual over theoretical. And the way I remind my students to help them remember the formula is A comes before T in the alphabet. So actual over theoretical. Okay, and then we're going to plug in the numbers now. So actual was 93 grams of calcium carbonate, and the theoretical is 104 grams of calcium carbonate. And notice that these are grams. Okay, and also notice they are the same substance, right? We're comparing the same product times 100, and then we do that on our calculator, which I've already done for you. No, I haven't. Where's my calculator? Oh, there we go. Okay. Here. Okay, so it's 93 divided by 104 equals times 100, and we get 89.4%. Okay, so that's a real simple problem. Just you're taking both your calculated product and then your actual product, and you're comparing them in this way to get a percent yield. Okay, now let's do the second example. Okay, now this one, well, let's read it first. It says 42.4 grams of aluminum react with excess O2 and 67.3 grams of aluminum oxide are produced. What was the percent yield of aluminum oxide? Okay, so we have 42.4 grams of this. We have excess this, and this right here, okay, this is not, it is that material, but that's not what you're going to put here. This right here is your actual yield. Okay, because remember, they're always going to give you, in a percent yield problem, okay, they're always going to give you the laboratory results, the actual yield. Your job is to find this. What is your theoretical yield? Okay. All right, so we've got to do some stoichiometry to figure out how much of this we can make with this starting amount. Notice that this is not a limiting reactant problem because you have an excess reactant. Okay? That means this is your limiting reactant, and this is the thing that's going to determine how much of everything else is going to be used up or produced. So let's do the first step, which is we got to change our grams to moles. Oh, sorry, the first step is to balance it. So let's balance. We have even and an odd. I'm going to double the odd, which means I need to put a 3 here and a 4 there. Okay, now it's balanced. We're going to change our 42.4 grams of aluminum into moles. So I'm going to use the molar mass of aluminum, which is 26.98 grams. Okay, and I'm going to take this times 1 divided by that, and I get 1.57 moles of aluminum. Okay, that's what I could put here, 1.57. Okay, this is excess. okay, which means I'm going to use up all of this. And what I want to know is this. Okay, at this point, I'm not going to make you fill in everything on the BCA chart. If you want to, that's up to you. Get more practice that way. But I won't be doing that on these worksheets. Okay, so it is to find this one, we're going to use our mole ratio, right? So we're going to take 1.57 moles of aluminum, okay, right here. And it's going to be want over half. So 2 of these guys for every 4 of these guys, or you can just think of it as a 1 to 2, which means this should be half of that, right? But let's just do it for the sake of this worksheet. 1.57 times 2 divided by 4, and we get 0.785 moles of aluminum oxide. That goes here. I'm going to make this 785. Okay, and also guys, if you don't want to use this chart, excuse me, that's okay. You don't have to use the chart. Okay, the purpose of this was for you to really understand what was going on with chemical reactions. Okay, now the next step is we need to find how many grams, because we're going to compare the number of grams of this stuff that on paper to this number of grams. So we've got to do a conversion, 0.785 moles of aluminum oxide, and we're going to use the molar mass, which is 101.96 grams per mole, and we get 80.1 grams of aluminum oxide. So this right here, this is my theoretical yield. Okay, so now we're going to answer the question from the problem, which is, what is the percent yield? So percent yield, remember, is actual over theoretical times 100. So I'm going to take my 67.3 grams of aluminum oxide divided by 80.1 grams of aluminum oxide times 100. And I end up with 83.98% yield. Alrighty, let's do the last one. Okay, 1.22 grams of oxygen reacts with 1.05 grams of hydrogen. Let's just go ahead and do that. To produce water, if 1.05 grams of water is recovered, what is the percent yield? Okay, so when you see this word was recovered, that tells you, oh, that's your actual yield. Okay, and what we need to do is find the theoretical yield. Notice with this problem, we don't know which one of these is the excess reactant, so we've got to do a limiting reactant problem here. So we're going to, first step is to balance it. So I have 2 of these, 2 of those, balance. Okay. First step, take our 1.22 grams of O2, convert it to moles. So 32 grams is 1 mole. 1.22 divided by 32, and I get 0.038 moles of O2. Yep. Okay, then we're going to take our 1.05 grams of H2. Divided by 2.02, and I get 0.5198, so I'll put 520 moles of H2, 0.038, 0.520. Which one's going to run out? It looks like this one, so let's check it. So if I do this, Okay, use this as my limiting reactant, which means it's going to determine everything else. So I'm going to figure out how much of this is going to get used up, and it's a 2-to-1 ratio, so it's double that. So 0.038 times 2, 0.076. Yep, that's going to work, right? If I did half of this, it'd be like 20.25. We don't have enough there. Okay, so this is my limiting reactant. So this is going to determine how much product I can make. And it's going to be also a 2-to-1 ratio. So we're going to make 0.076 moles of water. Okay, so now let's take this 0.076 moles of H2O, change it into grams. Molar mass of water, 18.02 grams is 1 mole. So I'm going to take my 0.076 multiplied by 18.02, and I get 1.37 grams of water. Okay, so this is my theoretical. This is my actual. So to find my percent yield, 1.05 grams of water divided by 1.37 grams of water times 100. Well, 1.05 divided by 1.37. And we get 76.6% yield. Okie doke, so that's how you do percent yield problems. I'm going to put this on page 98. All right, see you later.